In this video, I will show you how you do your problem-solving video. I've created a document on Google Presentations, and it's a very simple, plain white background with a title, and it's going to introduce the topic. So it says here, I'm going to solve a double slit problem. Now, what I will do is I'll click to the next slide to show you the problem, but the reason I chose this slide is because it's white and it's easy to write on. I'm actually using a smartboard to do the writing. You could do this however you like. You could actually type it out ahead of time and just advance through the frames as it's being solved. Writing it's a little bit easier, I think. That's what I'm going to go with. But let me show you how it's done. So when I click ahead here to this next slide here, it shows the problem down here on the bottom, and I've created a diagram ahead of time to avoid having to really write a ton of things here. So again, what I would be doing is I'd be showing how to do this problem. So according to the problem that I have here, it says determine the distance between the first and second bright fringe when a 50 nanometer light source shines through 75 times 10 to the negative 6 meter double slit that's projecting light on a screen that is 1.5 meters away from the slits. All right. Now, what it's saying that I needed to do here is I wanted to point out the given information. So what I have going on is that I have a wavelength given, of 550 nanometers. Now the next thing that I'm going to do is I'm going to show the calculations. Now the reason I drew this picture is to show the fringes. So I would indicate that this is fringe 0, this would be fringe 1, and fringe 2. And I would be solving for this. So you can kind of see where I'm going with this, and that I'm basically just simply calculating on the paper. Now I would show the equation that I would be using here, which would be this. The sine theta equals m times wavelength over d. And basically I'll show this calculation for both fringe number 1 and fringe number 2. And then I'll take the difference. So I would explain what I was doing throughout the problem. So I would first indicate what I'm solving. I would do sine theta equals, now I would work with fringe number 1. So this is fringe number 1. I would put in 1 for my value. I put in the wavelength they gave me of 550 nanometers, which is 550 times, 10 to the negative 9, sorry, that's 550. Again, you're going to be more professional than I am here. I'm just showing you how this works. The distance between the slits was 75 times 10 to the negative 6th, which is also a typo on there, what I'd have to go back and fix later on. While I'm at it, I would also show that I would do the same thing, but for fringe number 2. So I'd do sine theta equals fringe number 2, though, times all the same values. And I would just simply finish writing this out and solve it out. Now, what I would get here for my two answers would have been that theta would have equaled 0.84, and over here, theta would have equaled 0.42. All right, now you guys would probably find that this will be easier for the person who's operating the computer to actually do the speaking while the writer writes, so you don't have to kind of keep track of what you're writing and what you're saying at the same time. But if I were to continue the problem out, I've left myself enough space here to solve out, and what I can then do is I can then say, okay, well, from this point when I get these angles, I now need to find the distances that they're going to be. And if we look, then we have some right triangles here, so it would indicate in my problem that I'm solving out the legs of a right triangle. And according to this, I would be solving out the height, which would be my theta that I solved here will be the opposite angle, and the adjacent, meaning I'm going to be doing tangent, so I would do tangent of 0.42 equals the opposite, which was, sorry, I'm losing track of my thought here, which is y1 over 1.5, and I would do the same thing but for the other angle, where tangent of 0.84 would equal y2 over 1.5. I would solve out my two numbers, and I would see that I get an answer of theta y1 equaling 0.011 meters. And I would do the same thing with algebra and get 0.022 meters. Hopefully one of the things you noticed here is I didn't go through the actual steps algebraically. I went through the actual procedural steps and was explaining what I was doing and why I was doing it. The final point that I would make here is that the difference between, or the distance between 1 and 2 that I was referring to earlier right here, That distance is the difference between y2 and y1. So the value I'm actually solving for is delta y, and it would be y2 minus y1. And I'm just explaining that, again, that's the difference between the two distances. And it just so happens that when I do that, I would get 0.011. Now, we could have also just avoided the math and known that the spacing is even all along, but if we didn't know that ahead of time, this would be a way to set up the problem. And I have now shown you how you set up a problem and solved it out using Screencast-O-Matic.